Welcome to the video lesson from Chapter 1, Section 3 on postulates. By the end of the lesson, you should be able to answer the question, how are points, lines, and planes related? Getting into some vocabulary, well, the section's titled postulate, but what is a postulate? A postulate is a geometric statement we can accept as true without proof, or an axiom. Now let's actually dig into some postulates. Postulate 1.1 states that 2 points determine a unique line, which should be fairly familiar. We can't create a line without 2 points. Postulate 1.2, if 2 distinct lines intersect, then their intersection is a point. Think of the coordinate plane from algebra. The x and y axis are 2 distinct lines and they intersect at the origin, creating a single point. And last one for right now, 1.3, 3 non-collinear points determine a unique plane. We discussed that a little bit in 1.2. In order to create a plane, the 3 points need to be non-collinear. Let's go ahead and take a look at example 1. It says points K, L, and M are non-collinear, which means, again, reviewing from the last lesson, that they cannot all be connected with one single line. So the job here is to name all the lines that can be drawn through these 3 points. So I will start with the red one, and I'm just going to go ahead and connect these points M and K. So those are my 2 distinct points, M and K, that create this line. So I will label it line MK. Picking a different color now, I will connect L and K in a line. Again, making it a line using the double arrows, and it doesn't matter if you make it LK or KL first when you are naming it, because it is a line. And then last one will be connecting M and L together, adding the arrows, M line, ML, so you need the double arrows on top of those capital letters. So that was just creating those 3 lines that can be drawn. Nothing else can be added here because these are the only way to connect these 3 points. If I was going to try to do it again, I would just be tracing over the red, blue, or purple lines that are already there. So let's move on to problem B then. It says, what is the intersection of line KL and KM? Well, KL, or LK as I had it, is the blue one. So here's KL. And KM, or MK as I had it, is the red one. So these 2 lines intersect, the red and the blue lines intersect at that point K. So that will be my answer, point K. So there's covers 2 postulates here, postulate 1.1 and postulate 1.2. 1.1 states that a line is created from 2 distinct points. And then the second one states that when 2 lines intersect, they intersect at a point. Example 2 asks for naming of all the planes that are represented in the figure. So it's important then from the postulate to know that we need 3 non-collinear points to create a plane. So when we have this pyramid here, if I make U, V, and T, there are 3 points. They are non-collinear because UV is a line and then VT goes in this line out here. They create a plane. And they create a plane, remember, they extend in all directions, forever and ever in all directions. So there's this plane here floating on the bottom. And then there's these other planes that are created using R. RUV is one, RVT, and RST. So actually, an RSU on this side here if I missed that one. So what we're really looking for here in this particular one is that the planes are really going to be the faces of this 3-dimensional shape. So I'm going to go ahead and look at some planes here. So I've already pre-made these planes. I'm using, they match up pretty good, but not 100%. But I'm using these like transparent little shapes so that we can see then how they match up, but how they do start to layer. You need to start to see that you're looking through the object and finding those planes. So when it comes to coloring this, there are 5 planes because there are 5 faces. There's this front plane that's created with RUV. this right one from RVT, the back one from RST, this red one here on the left from RSU, and then this green one down at the bottom using any mixture of these three letters, UST, USV, VTU, like any mixture of combination of three of those letters together, because none of them, you can't pick any three letters here and make a line. All of the points, picking three would make them non-collinear. We have a fourth and final postulate in this lesson relating points, lines, and planes. And that postulate states that if two distinct planes intersect, then their intersection is a line. Let's take a look at example 3. Name the intersections of the planes. So we have planes A, B, C, and D, E, F. Again, I've got some shapes over here, some transparent shapes. Let's see what I got. So A, B, C, let me see which one it is first. A, B, C are 3 points that are along this back. Like if I were to connect them, A, B, C, into a triangle shape, there it'd be along that back rectangle there. So in this example, this one, I actually need this blue one. So that's A, B, C. And then D, E, F, finding those points, D, E, F. D is at the bottom, E is also at the bottom, and so is F. So these are all three creating the plane that's the bottom of this triangular prism here. And from my shapes over here, this is going to be the purple one. Now, it's not going to match exactly just from my limitations from this program, but just know that there's this plane, because you have to remember that this technically, planes extend forever and ever. So even though we're drawing it small, like they can get as big as they need to be. So just try to keep it to match up with the shape. We'll bring it down, but technically it extends forever and ever. Okay, ultimate goal here is to look at where these are intersecting. So if I take this purple plane, where is it touching the blue one? Well, it's touching the blue one right here at this line CD. Again, trying to let it match up as closely as possible. So this line CD is where the blue plane is matching the purple one. So CD, line CD, would be the intersection of those planes. Let's take a look at the next one. So BCE, find those. B, there's on top, C's on the bottom, and E's also on the bottom. So if we connect them, we're creating this triangle, tracing this triangle that's in the front. A, E, F. All right, let me just go ahead before we get too far, and looks like this is my red triangle. So there's plane BCE. Again, remember it extends forever and ever. There's plane BCE. And then it's looking for AEF. Well, A is up here, E is down here in the opposite corner. So it's like crossing this top of this shape. So this top face of the shape. So it's going from A, E, and then over to F. So it's talking about this space here, the top of the shape. So the intersection of these planes is where the yellow is meeting up with the red. So the yellow and the red are meeting at this blue line at BE, as close as I can get there. So this line here is line BE. That's the intersection of those two planes. Final problem from example 3 is to start with the line of intersection and figure out what two planes are touching it. So I've labeled line AB with this green line here, and I've extended it because though we have a three-dimensional box, it helps to visualize these things as going forever and ever in either direction. So what are the two shapes that are touching this green line? So if I come and grab some of these shapes to help visualize this, okay, I'm just grabbing the yellow one because it's on top. And though it doesn't match up exactly, that is the top plane, and that would touch the green line. So I'm going to keep that one there. This one here I just used in the last problem, and that one only touches the point B. It does not touch the entire line. So this one is not useful. What's the next one here? All right, the purple one, remember, is the one from the bottom. So this plane on the bottom, though it can extend forever and ever in every direction, it is on the bottom. It is below that. And though it does intersect with the yellow plane, it intersects with the yellow plane out here, not up here. So the purple one is not going to help. So we've got the blue. Oh, yeah, let's do the blue one. That one came up next. So the blue one looks like that matches. So this one extends forever. This is the back of that box, the rectangle there. That has BA in it. It does touch that green line, and the yellow one touches the green line. Just to double check, this red one could be over here in this triangle. It does touch point A, but it does not touch line AB. So this one is no good. So to answer the question as to what two planes intersect, I'm going to say plane, well, I'm just going to pick any three ones. So B, E, F, those three letters from the yellow plane, and B, C, D from the blue plane. And those two intersect to create line AB. All right, so your notes now has a section for you to summarize, including a picture of the 4 postulates that this lesson talks about. So I do want you to go ahead and do that. Again, these are going to be your own drawings, so if you need to go back through the video lesson, please do so, flip through your notes, but just come up with your own examples and your own words for these 4 postulates. Now, before you get too much further, I do want to just go ahead and show you some more pictures of planes and what happens when they intersect. I think it's beneficial to see the multiple colors and the shading and things that happen. So when you have one plane, like this gray box here, again, it is a parallelogram that we use, those slanted boxes. You have to imagine that this goes on and on forever, everywhere. Okay, we just obviously can't draw that, so this is what we use for that. 2 planes can either be one on top of each other, like think of a sandwich, like there you have one layer of bread up top and one layer of bread at the bottom. And I say bread because I want you to think like flat squares, okay? Or the graham crackers of a s'more, like they are not touching. They extend forever and ever in all directions, but they're only 2-dimensional, so they go across and across. There's no up or down that makes them cross, until one of the planes is going up and down, and then when they intersect, they create a line. So 2 planes can intersect to create a single line. Now I've got one straight across and another one straight up and down, but they could be slanted, it doesn't matter. They create a line when they intersect. 3 planes can also have 3 horizontal or 3 vertical planes, it doesn't matter, but none of them are touching, so this is no points of intersection. You could have them all kind of standing up and they create a line there. And then in this one, they're creating a line here. Well, really, actually, the 3 of these are just creating a point. These 2, this line is only coming from the pinkish and the bluish, but when you put all 3 of them together, all 3 planes actually only intersect to create a point. So that actually steps it up a notch there. It gets a little bit more specific because of the 2 lines intersecting at a point. This concludes the video lesson for lesson 3 from chapter 1 on postulates. So now taking a look at answering the question of how points, lines, and planes related. And that is that 2 points make a line. 2 lines that cross make a point, and 2 planes that cross to make a line.